For the last year, Parker Solar Probe has broken records in speed, collected unprecedented data, and achieved the closest approaches to the sun ever. But none of these insights were detailed images of the sun directly. I mean, if we're heading to the only star in our planetary system, we want to see it up close and personal. So the European Space Agency and NASA have another mission: Solar Orbiter.
The Solar Orbiter really will have the first ever images from the sun's poles. So we have not, as mankind, not taken any images of the solar polar regions ever. We don't really know what it looks like, but we believe that the poles are what we need to observe to better understand the magnetic cycle of the sun. We're going to the sun because it really has a lot of secrets that we have not really solved yet.
So the Solar Orbiter is an international collaboration to support our growing knowledge about the sun. It will be imaging and gathering data about the sun's surface, magnetic field, solar winds, and specifically, its polar regions. Now, scientists have flown a number of solar and heliospheric missions in the past, but nothing like the Parker Solar Probe and the Solar Orbiter, working hand in hand to paint a more comprehensive picture of what's happening on the sun.
The Solar Orbiter and Parker Solar Probe have a great amount of synergy. So Parker Solar Probe reached temperatures of over 1400 degrees centigrade, which is too hot to mount cameras. So Solar Orbiter will experience temperatures of just over 500 degrees centigrade, and that is just the range where we can still fly cameras to look at the sun. So Solar Orbiter will look at the sun itself and measure the solar wind flying past our spacecraft, and Solar Probe will measure the solar wind at a different location, even closer to the sun.
And understanding solar wind is crucial since it can be destructive to us on Earth. The sun resides nearly 150 million kilometers away from our planet. We can still feel its presence in the obvious light and heat it gives off. But beyond that, the sun's surface also creates sudden events known as transients. These include flares, coronal mass ejections, and shock waves. The explosive phenomena add to space weather, which affects the behavior of charged particles known as solar wind reaching Earth. This can disrupt radio and GPS communications, and even in extreme cases, lead to power outages. Every day, we become more reliant on technology to navigate our lives, so unfurling the turbulent nature of the sun is more vital than ever. So what exactly is on board the Solar Orbiter that will help the team see these coronal events in greater detail?
Solar Orbiter has a comprehensive suite of 10 instruments on board, and as the missions project scientist, I love them all equally. They're all great. So we have 4 instruments that measure the solar wind as it flies past the spacecraft, the so-called in situ instruments, and 6 remote sensing instruments that measure photons, meaning taking images of the sun and the surrounding corona and heliosphere.
The remote sensing equipment includes 3 different varieties of imagers: ultraviolet, visible light, and heliospheric, as well as a spectral imager, coronagraph, and an X-ray spectrometer telescope. Each of these instruments specialize in viewing what the sun looks like in either visible wavelengths, like what you and I can see with the naked eye, or in wavelengths we can't see, like ultraviolet waves coming off of plasma or X-ray emissions. The in situ instruments, on the other hand, include a magnetometer, an energetic particle detector, a radio and plasma wave sensor, and a solar wind plasma analyzer, many of which can be found on the boom in the shadow of the heat shield due to their sensitivity to the electromagnetic signatures of the spacecraft itself. So now that we've gone over all the delicate equipment on board, you might be wondering what a spacecraft heading straight to the sun does to protect its precious cargo, especially when Mercury, the closest planet to the sun, has its surface scorched to 430 degrees Celsius during the day. Solar Orbiter's secret? Equipment sheltered behind a powerful, multi-layered heat shield containing titanium, aluminum, and a material called solar black.
It has a massive heat shield that is actually larger than the spacecraft itself. It's about 3 by 2.5 meters, and it protects us from the huge amount of heat that we're getting from the sun.
In the front, the heat shield is coated with solar black, a material made from calcium phosphate that can tolerate ultraviolet radiation and energetic particles without degrading. Behind that is a thin 0.05 millimeter surface layer of titanium foil, backed up with 18 layers of titanium insulation. The structure also includes an aluminum honeycomb support panel, carbon fiber skins, and more insulation and gaps between it all to redirect heat to the sides. In total, the sides of the spacecraft will experience temperatures of less than 50 degrees Celsius, which is nothing more than a really hot summer day. With everything in place, this mission is set to launch in February 2020 aboard the United Launch Alliance Atlas V rocket from Cape Canaveral. If for the next decade, everything goes to plan, we will know more than ever about the star our lives all depend on. Want to know more about Parker Solar Probe? Check out our episode here and make sure to subscribe for all your rocket launch news. If there are other missions you'd like us to cover, let us know down in the comments. Thanks for watching, and I'll see you next time.